Section 2.5. Section 2.5 is about transformations. Okay, this is something we went over extensively in Algebra 2, so this is definitely just a review, but I wanted to talk about it with you just real quick. Okay, recognize graphs of common functions. Use vertical shifts to graph functions. Use horizontal shifts to graph functions. Just a reminder, we really talked a lot about this in Algebra 2. I'm just reminding you how important this F is. Okay, don't forget that F in that word. Okay, if you forget it, it's a totally different word. Okay, use reflections to graph functions. Use vertical stretching and shrinking, horizontal stretching and shrinking, and then graph functions involving a sequence of transformations. Okay, so recognizing graphs of common functions. When you left Algebra 2, there was probably 10 functions that you should be able to recognize. So let's see if you still recognize most of those. Okay, maybe an 8. It doesn't matter. What parent function is that? Y equals x, right? Can I start again? That was a bad example, so I'm going to start over. Okay, so there's the graph, and then here is the parent function. So that's y equals x, and that's the linear parent function. Okay, because it makes a line. Okay. Thank you very much. That's like the one thing good that's happened in my day so far, so that's good, right? Okay. All right, so the next one we talked about was this one. Okay, remember what that one is? Y equals x squared, so that's a quadratic. And it makes a parabola when we graph it, right? Okay, we also talked about this one. Absolute value, so that's y equals the absolute value of x. Right? Then there was this one. Well, that's not exactly true, but we'll start here. Because there was also this one. Yeah, those are both exponential, right? Y equals b to the x power. Excuse me. This one was where b was greater than 1. And then this one was where b was between 0 and 1. Increasing is when b is greater than 1. Decreasing is when b is between 0 and 1. Remember those? Okay. Then we had this one. Remember that one? Close. As in, you got the y equals right. Okay. It's called square root. Okay. We also had this one. And this one. And I'm going to go ahead and draw both of them because they're pretty closely related. Remember which one is which? That was your guess from a minute ago, right? X cubed. Okay. So that is a cubic. So this one would be y equals the cube root of x. And then we had this one. Remember this one? That was really loud. It does, yeah, it does have an asymptote. Oh, I thought I put it in here. No? Oh, there it is. I'm just checking to see what I missed. I missed that one. Okay, so this one is y equals log base 2 of x, right? Logarithm. was this one. And that was y equals 1 over x. Remember what that was called? Starts with an R. It's rational. Yeah, it's a fraction, right? Rational, ratio. Okay. I know that there's this one that you're going to need to be able to know. Like that. It is a piecewise function, yes, absolutely, but it's an integer function. Let me see how they want me to write the equation. I want to write it the same way. Yeah, of course it's not there real quick where I can find. I know that it does this sometimes. Okay, it literally says integer, int. Okay, I know it shows up that way sometimes on some of your homework problems. So whether that's like all the way correct or not, at least we have a starting place for that. Okay. So the ones in the book, oh, let me draw one more because there is one more in the book. And that's y equals c, and that's a constant. Okay. The ones in the book are the constant. There we go. Presidential alert. Mine didn't go off. Does that mean mine's broken? Okay. Mine didn't go off though, so the president doesn't care about me? I guess not. Okay. I'll add him to the list. Okay. So these are the ones that are in the book, okay? I'll put a star by them so you know for sure. I wanted to go back over all the ones we did in Algebra 2 because I still want you to be familiar with those, okay? But this one's in the book. The constant, linear is in the book. Absolute value, quadratic, square root, cubic, and cube root. Those are the ones that are specifically talked about in this particular section in the book. Okay? Okay, there goes more people's. And mine is still not gone off. Okay, that's all right. Okay. Maybe so. Okay, any questions so far? You okay with that? Anyone? So, recognize graphs of common functions. Are you comfortable with that? Yes? Okay. You're fine. I know you're distracted today. It's okay. Okay? I mean, not okay, but just kind of okay. Vertical, horizontal shifts. Remember, okay, here's what we talked about in Algebra 2, and we're just going to go off of this basis. Now, a lot of the examples in the book are like this. We remember that for our purposes, y tells me that it is an equation, f of x tells me it's a function, right? But for our purposes, they mean the same thing, right? Okay, so we're going to say a plus or minus a, x minus h. We'll just make this a quadratic because you guys are most familiar with that, okay? Plus b, plus k. Sometimes there's a b right here, and I think we should probably talk about that just in case. Okay? So when we have something being added or subtracted, both of these two terms right here, h and k, are things being added or subtracted. Those cause shifts. F, remember your F, okay? Those cause shifts. If it's inside of the function, see how this is inside of the squared part? If it's inside, then that is causing a horizontal shift. If it's outside, like the K is, that's causing a vertical shift. Oh, sorry, I didn't realize you couldn't see it. My fault. Okay. Outside causes a vertical shift. Okay. Now inside, remember, it's weird because it's x minus h. The minus is part of the equation, part of the given formula for us. So if it says x minus 2, we're actually shifting to the right 2. Even though it says minus 2, remember minus is part of the equation, so we're moving to the right. The way we talked about it before was if it's inside, it's kind of opposite of what we think. We see a minus, we go right. We see a positive, we go left. It's not that way for outside. Outside's exactly what you think. If it's plus, you go up. If it's minus, you go down. Okay? Things being multiplied cause not a shift, but a stretch or a shrink. Okay, let me make sure I'm using the right vocabulary. They use stretch and shrink. So yes, a lot of times in Algebra 2 we talked about compression because our book says compression. Okay, but that means the same thing. Okay, so it causes a stretch or a shrink. Again, if it's inside, which is what B is right here, that causes a horizontal shrink or stretch. And then if it's outside, that's a vertical change, a vertical stretch or compression. Okay? Now A does something a little bit different. The sign of A determines whether we have just the regular function or a reflection. Okay? If A is negative, if it's a negative A, then we have a reflection. We have a reflection over the x-axis. Same thing kind of for B. B does cause a reflection over the y-axis. So I guess I could have put a plus or minus in B, but now there's not room. So I guess I could try anyways. Okay. You guys remember most of this stuff? Good. Okay, good, good. So really the last thing you have to do is graph functions involving a sequence of transformations. So if it said something, for instance, y equals negative 2 times x plus 4 squared minus 3, you've got to be able to know that there's a reflection over the x-axis, a vertical stretch by a factor of 2, a horizontal shift to the right 4, and a vertical shift down 3. So whatever function it is, in this case it's a parabola, okay? Whatever function it is, you have to do all those things to that particular parabola based on its parent function, okay? Sometimes it might say f of x and it gives you just a random graph, like, I don't know, I don't want to do a dumb one, like that, okay? And then it says we want to do f of x minus 3 plus 4. Well, it's saying we need to move it to the right 3 and up 4. So if these were all like that, you know, kind of things, whatever, I need to go 1, 2, 3. So it starts right, well, over 3 and then up 4. 1, 2, 3, 4. So the shape didn't change because there's no multiplier. So it would be like this. The whole shape would move over 3 and up 4.
So that doesn't go replace x with x.
No, not in this case. Okay? Normally it would, but it's just saying take this function and move it to the right 3 and up 4. Okay? Well, and here's the deal. It just gives you the function and it doesn't give you an equation. There's no equation for this, right? So it's just a different way to write, move to the right 3 and up 4. take whatever function you were, and it puts it inside so you know that that's a horizontal change, and it puts it outside so you know it's a vertical change. Okay? Any questions about that, guys? Okay, so those are all of your objectives for 2.5. If you have any questions, just like always, just come and ask.